Yashvir Singh. The recording date is the 30th of March, and my tutorial number is H138, and this is my version of the week 7 Excel solution. So let's get started. So first we want to do is convert the CSV file to the Excel workbook. So this has already been converted, but it's pretty easy. You get your CSV file and you just save as and select Excel workbook as one of the first options. Now we want to create new variables based from this data set called mean and standard deviation. And we want to use the VLOOKUP function to extract the mean and standard deviation for each value, for each product based on the department. So VLOOKUP, we want to look at B2, the table array. Now usually you can just select the whole table here, but sometimes this can result in NAs when you try to apply the formula to your whole column. So instead, what you should do is do K and then do $, and then 1, and the end range is M $7. So that captures the whole table and it keeps that value static, like the range static, so you can apply it to the whole column. The column index number is 2 because that's the mean time until failure, and we want an exact match. So we get 6, and we just apply it to the whole column. Yep. And the same formula can be applied to the standard deviation. So again, we look up value, kitchen table array is K $1 to M $7, and this time, index number is 3, and then again we want an exact match. And then let's apply that to the whole column. Cool. So that's step 3 done. Now we want to simulate times until failure. So it says add a new column called random number and simulated time until failure. So in the random number column, we want to do a random number, let's close bracket, and then apply, give you a random number from 0 to 1. And now what we want to do is we want to simulate a time until failure using the normal distribution. So the way we do that is we use the formula. So let's keep, because these numbers keep changing, let's Control C and then paste the values so that the numbers won't change. So to do the simulated time until failure, we use the normal dot inverse formula, and in brackets we want to use the first cell under our simulated time until failure. So in this case, we want to use the random number, the first random number that we have. So in this case, it's E2. And then we want to use the mean time, so that's C2. And then we want to use standard deviation, which is D2. And then press enter. And then that applies to the whole thing. In this case, it won't change. Usually this will change if the E wasn't static, but in this case, it won't change, which is good. So now that's step 4 done. Now we want to you calculate a 95% confidence interval for the value. So to do that, what we want to do is we want to create, say, like a new column called mean time to failure, and let's call this one standard error. So to do mean time to failure, it's just average of where we've stimulated the mean time to failure, so F2 to F301. 301 is the last thing. Get this standard error. To do this, we have to use the standard deviation formula .s. So in this case, it is F2 to F301 divided by the square root of the number of the observations. So with the square root of, again, we want to use count F2 to F301 double bracket. Cool. So now we have the mean time to failure, we've got the standard error. Now we want to calculate the 95% confidence interval. So the formula for that is mean plus or minus the z-score times the standard error. So for a 95% confidence interval, the z-score will be 1.96 for a large sample size. So the lower limit and the upper limit we want to calculate. Lower limit will be this, so mean time to failure minus 1.96 times standard error. So standard error will be in cell I8. The lower limit is 6.97 and the upper limit is again plus 1.96 times standard error here, 7.58. So yeah, this approach gives you a 95% confidence interval for the mean time to failure across all the items, and this is the range, this is the estimate range within which the true mean time to failure for the entire population of items is likely to fall between 6.97 and 7.58. Thank you.